All right, welcome back. Today, we're not just, studying another chapter. Nope. We are launching a full-on strategic mission to absolutely conquer gravitation for your NEET exam. This is not about just memorizing stuff, it's about mastering it. You ready? Let's get into it.
Okay, first up, look at this. 2 to 3. Just a number on a screen, right? But what do you think it means? I want you to really think about it in terms of your final NEET paper. What could 2 to 3 possibly represent for you? And there it is. That's the number of questions you can pretty much guarantee you'll see from this one chapter. We're talking about a serious chunk of your final score, just right there for the taking.
So the big question is, are you ready to lock those marks down? Because that's exactly what we're going to do today. I'm here to show you how.
Okay, let's get started. First things first, every single good strategy starts with knowing exactly what you're up against. So, step 1, let's identify our target.
So why are we zooming in on this chapter? Simple. Gravitation isn't just another topic. It's what we call a high-yield opportunity. The questions they ask are consistently concept-driven. They're application-based, which is great news for us. It means if you just get the core ideas, you can solve the problems. It's a predictable and super valuable target.
All right, target acquired. Now it's time to survey the terrain. We need to break this whole chapter down, piece by piece. We're essentially mapping the battlefield.
I want you to think of this slide as your complete battle map. Seriously. Over on the left, you've got all the key concept areas, everything from Newton's law all the way to Kepler's laws. Then, in the middle, you can see the typical kinds of questions NEET loves to ask for each of those areas. And finally, on the right, the must-know formulas. This is your one-stop shop, your guide to the entire chapter.
And this right here, this is where you focus your fire for maximum impact. We've looked at the past papers, and these are the absolute hot zones. We're talking about the variation in G with altitude and depth, escape and orbital velocity, gravitational potential energy, and definitely the conceptual side of Kepler's laws and satellite motion. If you nail these, you've covered the most important ground by far.
Okay, no mission gets off the ground with the right gear. It's time to assemble your essential toolkit. These are the non-negotiable, must-have-in-your-brain formulas you need at your fingertips. First up, the big one, the OG, Newton's law of universal gravitation. This is the bedrock, the foundation for literally everything else we're going to talk about. It defines that fundamental force acting between any two masses in the entire universe.
Next in the toolkit, we've got gravitational acceleration, good old G. This formula right here gives you its value right at a planet's surface. And remember, this is the value that changes with altitude and depth, which, let me tell you, is a favorite topic for NEET questions.
And then we have gravitational potential. Now pay close attention to that negative sign. That's a classic trap we're going to dive into a bit later. This is a scalar quantity, and it's absolutely crucial for all your energy calculations.
Escape velocity. A concept that you will see again and again and again. This is the absolute bare minimum speed an object needs to just break free from a planet's gravitational pull and never come back.
And right alongside escape velocity, you've got its cousin, orbital velocity. This is the exact speed a satellite needs to hit to maintain a stable, circular orbit. Now look closely at the formula. Notice that subtle difference compared to escape velocity? It's that factor of the square root of 2. They love to test you on that relationship.
And finally, we have Kepler's third law. You know, NEET just loves to throw conceptual questions at you based on this one. It's really all about proportionality. The square of the orbital period is directly proportional to the cube of the orbital radius. Simple as that.
So, you've got the map, you've got the tools. What's next? Practice. It's time to put it all to the test. Let's talk about running the simulation, how to use mock tests to get ready for the real deal.
Okay, take a look at this. This is basically what a typical mock test in, the real exam actually looks like. It is not just a wall of impossible questions. Not at all. You can see the vast majority are easy or moderate. Your job is to be lightning fast and super accurate on those, which buys you more time to tackle the trickier ones.
And this table, this is where your strategy really comes to life. It's all about how you manage your time. For the easy questions, you should be aiming for, well under a minute. For the moderate ones, maybe a little over. This strategic allocation of time is every bit as important as knowing the formulas. It's how you max out your score when the clock is ticking.
And for our final section, let's get into the pro-level stuff. We're going to cover the elite strategies and the common pitfalls that separate the top scorers from everyone else. These are the winning tactics and the traps to avoid.
Here it is, your 6-step game plan for success. First, solve a good chunk of questions, like 40 or 50, under a strict timer. Then, and this is the most important part, you have to analyze your mistakes, every single one. Keep a running list of formulas and traps in a little notebook. Constantly revise previous year questions, and always be targeting your weakest areas. This is active, intelligent prep, not just mindless repetition.
Let's talk traps. Trap number 1, and it's a big one, confusing potential with field. You have to burn this into your brain. Potential is a scalar, no direction, and it's usually negative. The field is a vector. It has both magnitude and direction. Do not mix these two up.
Oh man, this next one, it gets so many people every single year. When you're doing satellite questions, you have to read the question so carefully. Are they giving you the orbit radius, which is measured from the center of the Earth, or are they giving you the height, which is measured from the surface? Your entire calculation will be wrong if you mix these up.
Okay, and here are a few more quick-fire traps to look out for. First, messing up sign conventions, especially with potential energy being negative. Forgetting your units or prefixes, kilo, mega, all that stuff. And finally, not reading those tiny but crucial qualifying words like minimum or at the surface or from infinity. You gotta know, attention to detail is everything here.
So there you have it. We've covered the target, the map, the tools, and the tactics. You have the complete strategic breakdown. So, I have one final question, and this one's for you. Now that you're armed with this entire plan, which one of these common traps are you going to make absolutely sure you don't fall for? Really think about it. Make it your personal mission. You've got this.